Yes. Okay, guys, let's start with 8.5, which actually is really more 2.5, I suppose. I think it's our 8th unit of the year. Rational zero test. So this seems very, guys, quiet please. Thank you. This seems a little confusing with all the letters up there. Let me just explain what this really means. What it means is that a rational zero is an x-intercept of f of x that can be expressed as a rational number. That's what a rational zero is. It's a lot of words, but I want to make sure you guys understand what that means. Now, do you guys know what a rational number is?
It's not. It's 0.3333.
Actually, it could be.
No,
No, not, it can be too. Listen to Connor. He's got it. Yeah, Connor's on fire there. So it's a ratio of two integers, or terminating decimal, or repeating decimal. So for example, 2 is 2. 2 is a decimal. It's 2.0, right? Or 2.0. Or can it be 2 as a fraction? Sure. 4 over 2, 2 over 1, 10 over 5, 20 over 10. What about 0.3 repeating? How do I write that as a fraction? 1 divided by 3, right? So 1/3 is also a rational number. So that's what's meant by a rational zero. It's an x-intercept of the function that can be expressed as a rational number. And a rational number is a ratio of two integers, or a number that has like a terminating decimal or repeating decimal. Eric, go ahead.
So the right number be rational?
No, pi's not.
Pi's not.
Pi just goes on forever, and there's no rhyme or reason to it.
Okay.
There's no repetition. E, Euler's number, like from natural log. Root 5. Squares, square roots of non-perfect squares. If you type the calculator, there's no rhyme or reason to it. So it doesn't lie. But obviously rational numbers is more vast, but yeah, there are a lot of irrational numbers that are out there. Actually, I'm not sure which one would be more. That's a good question, but anywho, let's keep moving. So now, what's meant by this P and Q thing? What's going on with P and Q? P represents the factors of the constant term. Q represents the factors of the leading coefficient. Okay. Q equals the factors of the leading coefficient. Now, when you divide those two together, that's going to represent the possible x-intercepts for your function. So let me write that as a text box. P over Q represents all possible x-intercepts for your function. Note, there's a good chance that none of those values will be an x-intercept, but it's possible. So that's what P over Q represents. When you do P over Q, we're going to do, for example, one just a sec. When you do P over Q, represents all possible x-intercepts for your function. But one thing to keep note of, there is a chance that when you list all the possible x-intercepts, it may not work. But it's just a theorem that does work in the sense that when you do find x-intercepts that are rational zeros or rational numbers, they will be part of that list. So for example, let's do example 1. So P is all the factors of your constant. So your constant is right here. What are the factors of -35?
-7, 5.
Well, definitely 1 in itself. And definitely 5 and 7, yes. And by the way, you have to put plus or minus because
17.
yeah, you could divide by negative numbers, right? It's not a big deal. And what are the factors of, we'll go pink here.
1, 3.
And by the way, this is supposed to be pointing towards that over there.
Yeah. 1 and 3.
Yeah, just 1 and 3.
So anyway,
Exactly. All right. Yeah, what are the factors of 3? Just 1 and 3, right? So when I do P over Q, what am I dividing? I'm dividing plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35, all over plus or minus 1 and plus or minus 3.
yeah.
Or it'll be plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35, plus or minus 1/3, plus or minus 5/3, plus or minus 7/3, plus or minus 35/3. So there's 16 possibilities because there were 8 factors of 35, 1, 5, 7, 35, and their negative counterparts. And of course, you divide by plus or minus 1, so it's the same thing. But also you can divide all those factors of 35 by 3. Plus or minus 1/3, plus or minus, sorry, plus or minus 1/3 is 2, plus or minus 5/3 is 2 more, plus or minus 7/3, plus or minus 35/3. So what this means that all those numbers written in blue can be x-intercepts of your function. Now, back in the day, before Desmos, when I say back in the day, like when I first started teaching about 17, 18 years ago, I would ask my students to do synthetic divisions with each of these numbers until they found one that got a remainder of 0. I'm not going to do that to you guys because now we're in 2023. We have the technology. In fact, even like AI, took a picture of it, like, so it's somewhere. So yes, yeah, whatever, right? It looks like the answers. But point being is that that's why we did this back in the day, so that excuse me. So you can see what could be possible, and then you would test them out. And again, there's a possibility that none of those 16 could work because the x-intercepts are imaginary or they're radicals. That could happen too. I won't do that to you guys. And again, I will give you an x-intercept that you can start with because I think it's kind of crazy to do trial and error. That's to do trial and error is just nuts. I don't want to do that to you guys. But all you would just do is you write that as your answer and that's it. You're done. So that's your answer. So those are all the possible rational zeros of that function. If you were to graph this in Desmos, you can see what the x-intercepts are. I did this with the other class, and actually none of those 16 worked. So I won't do that right now, but if you were punching in, none of those 16 would work. Because sometimes the x-intercepts could be imaginary or radicals. So now we're going to go a little more faster. Now you know what's going on. And again, these notes are pretty short today, so we should be done fairly soon. So you can put 15 right here and 4 right here. What are the factors 15, guys? 1. Good. What are factors of 4? Okay. I know you guys can divide fractions, so I'm not worried about or make fractions. So you can leave your answer like this. That's fine. I mean, technically, you should actually write out each one separately. Like you should say, there's 3 halves, there's 5 halves, there's 15 halves, there's 1/4, there's 3/4, there's 5/4, 3/4. There's also 1/2. That's okay. No, but it's tedious. I think you can write the answer like that instead. If you were to list it out, you have to write a combination exactly. Yeah. So that means that any of these combinations, in fact, I think it's about 12 combinations here. Any of these 12, is that right? 8. Yeah, 4 divided. No, it's actually just 24 combinations, I think. Just 24. Yeah. So in this case, there are 24 possibilities. Yeah, so anyway, let's keep moving. All right, now in this case, you're gonna have to solve for the x-intercepts. I will give you one of them. So here's what we're gonna do first. Let's write the possible rational zeros, get that out of the way. So it's called P over Q. So you have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. You're also gonna have plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, or plus or minus 15/2. So that's a total of 16 possibilities. There's 16 possible rational zeros. 1, 2, 3, 4, 2, 4, 6, 8, 10, 12, 14, 16. Again, if you just by trial and error, like if you just said, and don't write this down just yet, but if we were to just, let me just put these numbers here and let me just see if like 5/2 would work. I mean, you drive yourself nuts because you might want to do it 16 times, right? That's not terribly efficient. We had technology, so you don't have to do it 16 times. And it'd really be cruel and unusual punishment if I designed a problem where none of these 16 worked. That would also be cruel. So I wouldn't do that to you guys. I'm a nicer guy than that. So here's what we're gonna do. Use Desmos. Let me type this in the text box. Use Desmos.
So we use Desmos on the.
I'll give you one of the zeros instead.
Wait. Oh, and then we do synthetic division.
Okay, that's what you want to do. Use Desmos to find one of the zeros, and use synthetic division to find the other zeros. Guys, quiet, please. You guys are doing great. Let's keep this going here. So let me type this in. Shoot, let me get a copy of the notes myself. All right. So here we got 2x cubed. 2x cubed. Guys. Let's focus, please. Thank you, sophomores. Thanks. Yeah, and you too, Walden. All right. Okay. So anyway, just by looking at this, I see let me clear the screen for a sec. So that's the beauty about Desmos. This wasn't around when I was in school, but you guys have it. It also wasn't around when I first started teaching. So but you see 3 common zeros, one of the x-intercepts. You can either choose these two also. But what I want you to do is start with one x-intercept that's identifiable, that's a rational number. 3 is a rational number because 3 can be written as 3 over 1 or 6 over 2. So let's do it. So let me do that. Let's go green here. So now this I do want you writing down 2, 1, negative 16, negative 15. We'll put 3 here. And 3 is definitely a possible rational zero, right? So I feel like this makes sense. And remember, you bring the 2 down, multiply 2 by 3, which I know is 6. 1 plus 6 is 7. 3 plus 7 is 21. Negative 16 plus 21 is 5. 3 times 5 is 15. Negative 15 plus 15 is 0. So you get 2x squared plus 7x plus 5 equals 0. Remember, when you do synthetic division, the numbers represent the coefficients of your quotient, and you always go 1 degree less than the original function. This is factorable. I could factor it. I think it's 2x and x plus 5 and plus 1. I think that makes sense. I mean, you could do the little diamond box method that you like, but trial and error could work too if you could see it. So yeah, I get that. Your answer is a negative 5/2. And of course, negative 1. Definitely negative 5/2 I see right here. And definitely negative 1 I see right here. Right?
Numbers that aren't zeros, do those mean anything? Do those look like anything on the graph?
No, they're just random. They're nothing. No, they mean nothing. They're meaningless. Okay, so that's what would be a test question. A test question would be where I'll give you the function, I'll give you one of the zeros used. Actually, it's like the homework quiz today, right? This is just like the homework quiz. Where I give you one of the zeros and you use the division breakdown. right, let's keep moving. And we just got example 6 is really short. You got 2 more examples like this. All right. So rational zeros, let's do it. P over Q. You have plus or minus 1, plus or minus 2, plus or minus 4, over plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4. I'm not gonna list them all this time. I did it for example 3.
Wouldn't it be plus minus?
Yeah.
Oh, you're right. Yes, sorry. Plus minus 6. Thanks. Yes. My bad. Thanks for catching that.
What-
Yeah.
What is this where it says, we have the 2 on. But in the page. Where it says we're given no contact or something.
I don't know what that means. I'm not sure. Because these could have common factors. I mean, if there are common factors, I guess they would cancel out, but honestly don't worry about that.
You don't want us to cancel out.
No. What you have to do is you have to consider all the possibilities, right? Like you can have like all these divided by 1, all these divided by 2, all these divided by 3, all these divided by 6. I think what's good by now is that sometimes they repeat themselves, like obviously plus minus. So plus minus 2 or plus minus 2 is 1.
If you were to make this, what you're not. If you were to
Right.
make this,
Because it's redundant. Right. That's what's meant by that. Got it.
like we don't, guys.
But honestly, you're fine just saying this. This is totally fine. So now, let's use Desmos. So you're doing the homework today. Let's see what Desmos is going to tell us. So let's see 6x cubed. Let me clear the screen.
It's math equation to find the.
No. Nope. Nope. Pretty much, yep. Or technology. Okay. So I see 2, 0, right? Okay, cool. So I see a possible x intercept. So I'm gonna use 2.
Yes, let's go.
Okay. So the 2 on the outside. 6. Bring it down. 12. Looks like what? 12.
2, -2, -4, 0. Boom.
Very nice. I think it's factorable.
Um,
I think so.
Plus.
I got lucky. It's factorable.
How does it go?
Well, that's the answer to the last question.
Well, no, because like 6x squared can be broken from 6x and x, right? I mean, you could do this if you guys want. Like that's -12 and 1. So right, 4 and then you have to do factorial grouping after that. This method here, it's not that bad. Yeah, if so, once you do the diamond, then you have 6x squared plus 4x. Yeah, and then you do this. You factor out 2x.
You just draw off.
You can do diamond factor by grouping, or let me show you the box really fast in case you're curious. Here's how it works. It's really, you still have to do the diamond to know how to break it apart. I just did it right now.
Like, what did you get?
I did 6 times -2 is -12. And then I put the middle number, which is 1, the middle constant. So the middle coefficient. Right. So here I'm gonna put 6x squared and -2. I'm gonna put 4x and -3x because that's how I broke apart the middle term. And then I could factor out a 3x and a 2 and a 2x and -1. When I taught algebra 1, this is exactly what I taught factoring. I taught like this. So that's the box method. And of course, x equals negative 2/3 or 1/2.
Too easy.
Yeah.
Boom.
So whatever you guys want to factor by trial and error, you want to factor by grouping, you want to factor by the box, I don't care. Whatever works for you guys.
Yeah, then you take the choice. Before they we split positive x.
Every time I go
So x
through
next to x is positive x. Plus then yes. And this is the first and last term. You factor along by the row. Is that you? And that will be your yes. Final product.
Okay. So let's keep moving, guys. Now, fortunately here, you can just factor right away. I'll show you how. Both. Yeah, before I do that, the P and Q business, plus minus 1, plus minus 36, plus minus 2, plus minus 18, plus minus 3, plus minus 12, plus minus 4, plus minus 9, plus minus 6. So there are a total of, yikes, 18 possibilities. But, you know, honestly, let's just factor right away.
X minus 6.
Yeah, so you could do x squared. And what two numbers multiply negative 36 and add to negative 5? 4 and 9, yeah. But one's negative 9 and 4, right? So x is going to be plus or minus 3. Or x is going to equal plus or minus 2i. Because that's imaginary. I know, terribly exciting. No, you can't. What do you mean by root?
Oh, because it's negative, so then.
Yeah, no, you have to factor, yeah, you have to do a big that 0.
You wrote it as is negative 4.
Well, you factored incorrectly, right? So now let's go to Desmos really quickly. Let me clear this. I'll put it back in a sec. All right, good luck to you, Luca and Walton.
Got this.
All right.
I know.
Okay, make sure you break par. All right. So, you guys quiet, please. So here's the deal.
This graph only shows 2x intercepts. When you have your degree of 4, the degree of 4 indicates you could have up to 4x intercepts. However, that's not always true. This only shows 2x intercepts. So the other 2x intercepts didn't show up because they were imaginary. So now you're starting to see the graph from algebraic now. Algebraic is just smaller, right? We have plus minus 3, plus minus 5. Graphically, just put a Desmos, you see 2x intercepts. The other two don't show up because they're imaginary.
So like if it was
That's why you need to take division sometimes or factoring to find out the other x intercepts. So the graph sometimes won't reveal all the x intercepts. Or if they give it to you as a radical, as a weird decimal, that means it might require quad form somewhere along the way.
is there ever a chance for it to be like 3x intercepts and then just is an n dimensional one? Or is it,
Well, if it's 3, you're going to cross at least once because of the end behavior. But there's a possibility you could have x to the 4 power and it never touches once.
so we have imaginary.
You have 4 imaginaries.
So the imaginary is always filling.
Yeah, you can have something kind of like that's you can have something.
Yeah.
That's an imaginary.
You can have something like this, Damon. It'll be like that.
It's a W.
Back to Warriors. All right. Okay, one more, guys, and we're done.
You heard De'Aaron Fox focus on
You did he really?
or changing side. He's doubtful for games.
No, he's gonna play.
Yeah.
Yeah, I thought-
He's gonna be shot. It's on a shooting edge too.
Maybe we'll win. I was wrong.
Yeah.
I thought we were screwed after game 2. No, seriously, I was. Yeah, they didn't, but you know, they both teams feed off the home crowd really well. So
I asked my Snapchat AI.
I haven't seen what the line is, but yeah, it'll be fun.
They said that Draymond Green's gonna lead the rebounds down 12 rebounds.
That's your AI said. Okay,
Yeah.
all right,
It's not good.
Yeah, it's never wrong.
all right. Anyway, for this problem here, I don't want you writing in standard form. That just takes too long. That's a lot of foiling. That's not necessary. The bottom line is this. You need to have linear factors. So like x minus a number. If -6 is an x-intercept,
Of course, x plus 6 is a factor. If x2 is an x-intercept, of course, x plus 2 is a factor. That's where it came from. If 3 halves is an x-intercept, x minus 3 halves would be a factor. Or you rewrite this as 3x minus 2.
But in terms of foiling, I don't really care because you guys have done a lot of foiling in your lifetime, so it's not necessary to do that for this problem. So I crossed off the standard form. I don't care for that. I know you guys can foil.
Right as far as.
Yeah, that's that. So where did it come from? Yeah, I'm done. Yeah, done.
Oh, you just gotta write that up.
Yeah, that's all. Whenever, so this is funny, like whenever you're told to write something, literally that's what you're doing. Even when I was in grad school, like we had classmates that we would feel like they had to do a lot more to the problem. The professor's like, no, just write an answer. That's it.
There's a freshman.
There is. That's psychological. Okay, let me end the video.
Graduate.
Material science.